Here's what we're doing. Tomorrow, we are graphing radicals. And there is a long, yucky way to do it, and there is a very cool, shortcut way to do it. And the shortcut way to do it is to just do this really cool little flip thing. But before I can show you the shortcut, I have to explain why the heck this shortcut works. So we're going to take a brief detour and talk about kind of a different thing. Oh, it's going to be me in a second. Does that frighten you? That was a scary sound. And people were like, ah. We're going to take a brief side tour and talk about the word inverse in math, right? And sometimes we think of inverse as being backwards or opposite or flipped, right? So if you have me and I am your teacher, and you'd say, oh, today inverse Mrs. Tarantino is going to teach, that doesn't actually mean that I come in and I am upside down, right? That's not really the inverse. That's just me trying to do like a circus act, right? So let me tell you what the true inverse of me is. And this is, honest to God, the truth, because inverse does not necessarily mean bad. It just means kind of the complete undoing. So here is me. This is the things that I do as a teacher. I sit in table, we have table groups. I don't use a textbook. I am very loud. Poor Mrs. Honey. I'm super loud. I am very snarky and bitchy, right? That is who I am. Honest to God, that's who I am. And do you know who the inverse of me is? The inverse of me, the anti-Mrs. Tarantino, is Mrs. Landry. And here's why. She teaches in rows. She teaches, she follows a book. These are both things that work for her. She has a very quiet, peaceful demeanor, and she is not a snarky bitch, right? She's very kind. She's very kind. So she is literally the inverse of me. If you wanted to say, today we don't want Mrs. Tarantino, we want the inverse, it would be Mrs. Landry and I meeting halfway, high-fiving each other. I would go be the inverse of Mrs. Landry, she would be the inverse of me, right? So what it does is it doesn't just flip things upside down, it kind of turns things inside out completely, right? It turns them inside out completely. So today in math, we're going to talk about inverse functions. But when we do inverse functions, what we're doing is we are going to be changing people's places. The inverse of me would be if I changed places with Mrs. Landry. I couldn't be the inverse of Mrs. Tarantino. It's not possible. I cannot be not a snarky bitch. It's not possible for me to do. So the first thing that I want you to write down on your back so the paper with the graphs is what we're doing. I want you to write this. The inverse of math is this. What we are doing today is we are actually flip-flopping, not negatives and positives, we're actually flip-flopping X's place with Y's place. We're saying that X and Y are kind of opposites of each other. They are the inverse. So when I want the inverse of Mrs. Tarantino, it is not me wearing my clothes backwards, it is not me coming in upside down, it is me switching places with my inverse. So today, we're talking about flipping the X and the Y's place to get the inverse, right? The reason we're doing this is tomorrow, the easiest way to graph a square root graph is to graph this guy first and just flip him over. That's all we're going to do. It's so easy. But I have to explain why that flip thing works, and it's because of inverse. So here we go. We're ready to do this. Do you want me to go back? So what we're going to do is I'm going to give you a function, and we're going to find the inverse of that function by flipping the x's and the y's place. Now, I know you guys don't like doing a lot of math. I know you like counting, and that's what I like doing. So we're going to do this all by graphing, and Kelsey's going to like it a lot better tonight because you're like, oh my God, this is so much easier. But here's a couple things that you need tonight. I would say a second color pencil makes this easier, and a straight edge. So I have passed out a number of rulers. I have a few more. If you don't have a ruler, one of the best things you can do is just take a piece of paper, fold it twice, right? So you get a nice straight edge, because you're going to need to make these lines pretty perfect. Not perfect, but pretty perfect. It'll make your job nice and easy. There's very little math. Now, I will say this. Some people in this class are going to see this automatically as we do it. And for those people, I feel like I'm saying it to Marina, who's very spatial. I hate you, yucky for you. I can't do this. I have to take steps. But some of you are going to be like, I can just eyeball it. And I'll be like, shut up. Yay you. But if you can, that's awesome. I can't, because I'm an idiot. So here's what we go. Everyone's ready. This is what we have. That's our function. We're going to want to write the inverse function, and the way we write, we don't like writing the word inverse over and over. So the first thing that you need to know is this. The shortcut for writing the word inverse is to use the little accent mark. In math, we call that primes. So we have f of x, that's our first function, and we're going to be looking for his opposite. We're going to be looking for his inverse. We're going to be looking for his Mrs. Landry, if you will, right? So here's how we do it. It's weird, but it's pretty easy when you get the hang of it. So the first thing that we're going to do is we're going to graph this baby. Are these going to be easy to graph tonight? So easy. But you may have forgotten how to graph a line, so let's do that together. Remember, there's two parts. There's the starting place, and then there's the slope, the up and over. Do you remember that? So we're going to start by putting a dot at 4. That's my y-intercept, right? And then we're going to graph our slope. How many up? How many over? So we're going to go up 2 over 1. Does that make sense? So what I'd like you to do is keep either adding dots, up 2 over 1, up 2 over 1, or get out your straight edge and keep going till you ram into the x-axis, right? So I have a hard time up here making a straight line, so don't judge me. I'm going to do my best here to see if I can make this line look decent. So let's see if I can make this work. Oh, that's not bad. Okay. Everyone have a line like that. Is everybody good? That's our first function. Now we need to find his nemesis, if you will, his inverse. And here's how we do it. It's so easy. We're going to take 2 points on him. Any 2 points you want, but I'm going to tell you, I have an easy time picking the points that are on the axes because I like zeros. You know me. It's easy for me to graph. So I am going to steal 2 points off the original line. So I'm going to take 0, 4 and -2, 0. Did I lose anybody at that? No? Who's not certain what I'm doing? Okay, so I have my line, and I'm picking 2 points off it. Any 2 points you want, but I like the ones that touch the axes because they make me happy. Okay? Yeah? Are we good? Okay. Here comes the magic. You guys ready? I'm going to do one thing real quick. I'm going to make this a different color so everything shows up in a different color because it's going to look cool. The magic is this. Here comes the math. It's really hard. You ready? It's really scary. Put the X's and the Y's. Yeah, that's it. So what we're going to do now, those 2 points are now the inverse function. So all we have to do now is graph those 2 points, draw the line, and we have now drawn the inverse function, and I'm going to show you the easy way of writing the equation with no math whatsoever. So what did I do to get to the inverse? I flipped them, right? Because that's what the definition of inverse is. It says flip your x and y's. So let's graph it. Are you guys ready? If you have a different color pencil, now would be a great time to use it because we're doing a new line, right? So there's a bunch all over the place. So here we go. I'm going to go 0, 4 and 0, -2. Is everybody cool with that? Okay. So now I'm going to draw that in, and I'm going to ask you to please use your straight edge here, right? I'd like you to use a nice straight edge here. Okay, we're almost home. We're almost done. And if you notice, we haven't really done any real math per se. So here's what I need to do now. Now what I need to do is write the equation of that line. And that is super easy without doing any math. As long as you can count, you can do it. Remember, it always has 2 things. It's got an x thing, and it's got what's added on. So I'm going to start with, where does my new purple line hit the y-axis? It hits right there at -2. So I'm going to say that's -2. And now it needs a slope. And how do you get slope? You start at a bottom point, and you count up to a top point. And it's super easy. So 1, 2 goes on the top, and 1, 2, 3, 4 goes on the bottom. And you have just found the inverse. Can you leave it like that? You can. Can you make it fancy and make it look like this by going ahead and doing a little bit of reducing? You can do that as well. I like that. Is it right either way? It absolutely is. Better, Kelsey? Yeah. Does that make sense? So we have started with the original one, and I found the inverse. Now, for those of you, I'm going to answer your question in a second. For those of you who are visual, and you're thinking, Ms. Tarantino, how are these opposites? Let me show you where the mirror is. The mirror is not where you think it is. The mirror, I'm going to show you. Let me get rid of this real quick. Watch this. The mirror goes right diagonally through your graph. So check this out. Do you see that mirror line? Marina, do you see how they're mirrored images? Does that make sense? I swear, it's visual people who can see this. Does some of you see that? Like, I feel like some other people who are more artistic than me, like, here's my original one, here's my mirror image, right? That's what I've mirrored it over. Yeah?
Are they like the inverse lines, so they're always gonna like cross over at like the...
They will always cross on the mirror line. Yes, they will, except if they're parallel.
One by one.
Yes, yes. And does that make sense? Because he's going up like 2 over 1, and he's going up 1 over 2, right? Because they're undoing each other. Great question. That was good. Yes.
So where does the -2 come from?
Oh, where it hit the y-intercept.
Okay.
Because that's always, remember, that's our starting point, our y-intercept.
Yeah.
Well, here's his,
Oh, okay.
and this is our slope, and I counted to find his. So you know what I'm doing? I'm undoing everything. I'm going back. Good questions. You guys ready to try a new one? Here we go. Okay. Now, I'll be honest. I checked some people's homework maps, and the problem wasn't. So, Jackson, you have choices here. Always. I leave you alone,
No, I know.
but you can't disrupt. Okay. So, here's what. I saw people who did beautiful inverses, but their first graph was wrong. So, Audrey, I'm going to have you walk me through graphing this first guy, right? So I'm going to do them in a black pencil. I'm just getting it ready. So can you tell me on that guy, what's my starting point?
-1.
Awesome. So good. So good. And then I'm going to go up how many and over how many?
1.
Up one. Awesome.
Over 2.
In which way? Negative direction or positive?
She went up left.
Yes, beautiful. So 1, 2, 3. That is awesome. That is awesome. So you know what you could have done? You also could have gone down and over 1, 2, 3. Beautiful job. Excellent job. Can you all graph that for me and make it not use your straight edge to get me the original function, right? Get me that original function in there. I am going to grab a pen here. And here it goes. I want it to be blue. Here we go. So here's my original. Please be good. Please work. Oh, this is so tricky for me. Okay, here's my original. Oh, I kind of missed, but it's not bad. Okay, that's my original. Okay, so here's what we're going to do. Steal 2 points. You can steal more if you want to, and it'll make a beautiful line, but you only need 2, right? If you're lazy, you only need 2. So I'm going to steal 2 points. I like taking the ones right here and right here. You know why? It kind of gives me the intercept right away when I graph. But it's up to you, right? You can take any 2 points you want. I'm going to use that one. That is -3, 0. And the other one is 0, -1. Nice and easy. Okay, here comes the math. We're ready. It's tricky. It's hard to go to the inverse of him. I have to flip him inside out. Instead of it being -3, 0, now it's going to be 0, -3. And instead of being 0, -1, it's going to be -1, 0. And now I graph that. I use a second color pencil because sometimes it gets kind of confusing, like which one goes with which one. So I'm going to use a second color. I'm going to go 0, -3. And I'm going to go -1, 0. Boom. I'm going to draw this in. Please don't judge my line here.
We will.
You will. I feel like you will. And back at you, Amanda, on this one. Look what happens when I draw that thing and look, it crosses right here on the line. Does that make sense? It's a cool way to check. Do you have to draw in this goofy mirror thing? You don't, but I do it because look how cool. It shows me that it worked. It flipped it, right? But you don't have to do that. If you don't want to do that, I'd kids say, that thing confuses me. That's fine. Now, the reason I like my other color is because that's going to help me write the equation. So here we go. We're writing the equation. We're not doing any work because we're that lazy. We're going to say f prime of x equals, it's always going to be blank x plus blank. I come down here to 1 to -3. And to get my slope, I went up 1, 2, 3, and then I went over 1 in the negative direction. There you go. There you go. I like these. It's a different way of looking at the math, right? Just a little more visual. Let's try one more together, and then I'm going to let you practice these. Here you go. So this is the last one we're doing together. Can you guys try this one? At least graph it by yourselves. I'm going to remind you, it's 1 over 1 there, right? Because if it's just a 1, it's up 1 over 1. I don't know, you made me think all day. Like when I was little, I grew up in Huntington Beach, and my dad take the ocean, but he'd take me like through the waves and deep, and I like hold on because I was little, but it was like he just said, "Come on, we can do this." Yeah, it was like the best thing. Thank you for that. That was my best. That was a Be Nice Friendly gift right there. Okay, so I'm putting my graph on here. You want to maybe take a look and see if your graph looks like mine. Hopefully it will. No, oh, it's just my beginning one. I'm not doing my other one, Dominic. Yeah. Okay. Hopefully yours looks like this, up 1 over 1, starting at 3. I'm ready to grab a few points from this dude. I'm stealing some points. You can steal anything you want. I steal those because it automatically means I hit the y-axis every time. Otherwise, if you take different points, as long as you keep your line going, you'll hit the y-axis eventually. So don't worry about it. So here's what I'm doing. I'm going to do, ooh, that's not what I want. I am going to do 0, 3. And I did -3, 0. And now here comes the magic of flipping it. I'm going to do it in red this time. F prime for me, I'm going to flip those points. 3, 0, 0, -3. I'm going to graph that bad boy. 3, 0 is over here. 0, -3. And Marina, again, this is one of the ones you could really easily just see how they translate over for anyone else who I know is artistic. I'm going to throw that bad boy up. Here comes my line. Oops, that's not what I want. I want to grab the red. Does it look like, oops, that's a bad line. Let me try that again. Oh, that's better. That's better. There we go. So I'm going to talk specifically to my girl Amanda. They didn't hit. Do you know why? Because they're parallel. But are they still being mirrored? Yeah, they totally are. Does that make sense? So this one's up here, this one's down here. But since they're never going to cross, it's okay. The slope is 1. Yep. So here's what my answer is going to look like this. It's going to be f prime of x equals my starting point was at -3, and I went up 1 over 1, or some of you went up 3 over 3. Doesn't really matter either way, either 1 over 1 or 3 over 3. It's totally fine. Totally fine. Again, for people who are not super mathy, this might be your day. This might be your day. That is it for me today. I'm going to pass out your homework. Your answers are on there. There are 9 of these. Cut off number 5 because we already did it. And cut off, let's cut off 1 more. Do 7. Do 7. And I just have to watch. If I was a homework, where could you be all this? Oh, there it is. Okay, it's kind of beautiful in kind of a weird way, right? It's different. It's nice to do something that's not just so right? Yeah, because this is kind of, do you see this? I mean, it's kind of like visual, you know what I mean? I feel like these people really love math and do not love this kind of the answers are on the table. They're on the table. No! If you want to look at it. No, I thought it was just going to be the visual news. Do you like this or do you like more just math? I don't like that. Yeah. But these aren't fast, right? But it's going to make graphing the radical so much easier. And I feel like you're not going to like this. You make this at a radical itself, but not. No? That's so pretty. So you can skip number 5 and another one. It's really easy for me to check tomorrow because I'm just looking for your graphs on there. So it's super easy to check out 5 and another one.